going to start off with the different PTO sizes, 1,000 inch and 3/8 or the larger 1,000 inch and 3/4 PTO for the different sizes of tractors. The hitch has a double plate assembly, whereas this one will wear off in time. We can cut this one off by the use of a simple grinder and peeling this off and then replacing this hitch plate. The hitch pin is attached with a chain and the hair clip so it does not get lost or used on a different implement. The jack is the raise and lower position is right here. When we want to take this jack off, we put it in the jack storage area, which is right here. That allows the jack to be out of the way of the tire when the implement is turned left or right. Just some simple grease points. We have one on the universal joint in the front, one on the universal joint in the rear. If you open up the shield, there's two bearings, a pillow block bearing here and a flange bearing right here that take grease at 50-hour intervals. This overrunning clutch is washed in grease. There's two grease zerks, one left and one right. The reason for that is so the clutch in the inside has grease at all times, so it is able to activate. The reason for an overrunning clutch is so when the tractor's PTO is stopped, there's a clutch brake on the PTO, so the unit is able to free spin after a moment of time. Under the shield there's a white spoke that is painted so that the operator of the tractor can see if the distributor is in fact running. When this white spoke goes around, they can see from the cab that the PTO is running the distributor. On the belt tension, we came up with a simple technique to know the right tension or the proper tension. Just pass a dime and hold a nickel. The nickel does not pass through, but the dime easily passes through, and you know that you have the proper tension on your belts. The reason why we use a cog belt is for traction. It cleans better, and your traction is on the sides, and it is able to grip the sheave much better than a smooth belt. The apron chain tightener assembly has 4 grease points on the slides themselves, and then 4 grease points on the idler sprockets. There's one on the 8-inch channel on the outside, there's 2 on the slides in the middle, and then there's also the other one on the 8-inch channel on the left side. The sprockets, the idler sprockets for the floor chain, also have 4 grease zerks, so they turn with ease and do not bind up on the shaft. To grease the pivot point on the belt tightener assembly, the grease zerk is here, and that is at every 50 hours. On our systems, the bottom line is pressure and the top line is return. And if you follow that down, you can see where the pressure line and the return line goes to the cylinders and then to the orbit motors to drive the floor chain. In order to check the grease level in our hubs, we simply open this rubber cap and you can check a visual inspection if there's grease, gear lube or not. We use gear lube because the bearings will last a lot longer, and that's what over-the-road trucks use to haul 80,000 pounds. In the 20-ton, we use 75 psi of air pressure to inflate the tire to properly hold the load that you will put on your spreader. On the 20 tons, we use a 1620 military tire, which is 28 ply, and is a heavy-duty tire for this application. The 16-ton also requires 75 pounds of air pressure, and it is a 385 65R 22.5, which is also a 10,000 pound tire, and it is rated well above what we need to haul our load. As I said earlier, pressure is bottom in our system, and you can follow the flow through the cylinder and then to the orbit motor as I explain this. From the bottom of the pipes which come back from the tractor, they first fill up the cavity, open up the end gate, and fill the cylinder. From there, this circuit is full. You come to the next circuit, which is the orbit motor. Hydraulics works on the path of least resistance from the cylinder to the orbit motor, which means that the end gate will go up before the floor chain turns around. Following the path back to the tractor, the return line is the top. And as the gate goes down, the orbit motor will not turn backwards because of the use of a check valve. Under this shield we have a slide coupler. In order to take the distributor off, you simply slide this forward, remove a pin on this side and the other side, and lift straight up. And then you have your distributor off in a matter of minutes. After you remove the pins, lift on 2 equal points on the distributor straight up with either a loader and tractor or a forklift to remove the distributor. Just lift straight up and back and then back down. The reason why you would remove the distributor is to haul frozen manure, hay, or other materials that you do not want spread with the distributor. The use of chisel point teeth is a hardened steel, and they will last 4 times as long as a rooster comb. The chisel points acts as hands to bring the material off and spread it. You'll see there's a lot less floor pressure on the chain and a lot less pressure on each one of these teeth. The more teeth you have, the smaller the particle size and the better the spread.